The first half of 3, 4 we did on Friday, and we learned the first two factoring methods. And the first one was greatest common factor. Basically, you're just factoring stuff down. That was like number 1 through 6 on your handout, on your homework sheet. Okay. And then the second method that we learned was difference of squares. Okay, we're going to review that. If you feel like you need to write this down just to have an extra example, find a place on your notes to write this down or somewhere. If you don't, if you feel like you're good on this, great. Okay, but we're going to do these together. These are different problems. These are extra problems that we're just going to do together just so that we know that you're good. All right? So 3x to the 4th, y to the 7th, z to the 3rd. I'm writing this just straight from the board here. Writing this on this paper. Will you open that door for him, please? Okay, here are my two problems. Greatest common factor, difference of squares. All right. Now, when you're doing greatest common factor, it's really, really, really super important that you, really super important that you look and see how many pieces you have, okay? I have 3 pieces there, underlined in green. They are separated by pluses and minuses, all right? I'm looking at those 3 pieces to see what I can pull out, okay? So start first with the number that you have. I have 3, 6, and 27. What number goes into all 3 of them? 3. So I'm going to pull a 3 out, okay? Now the x's. I have 4 x's here, an x here, and 2 x's there. How many x's can I pull out? Just one, okay? This one has 4 to give me. Listen. This one has 4 to give me, but if this one only has 1, I can only take 1 out, all right? Y's. I have 7 here, 3 here, and 2 here. What's the most number of y's I can take out? Y to the 2nd, okay? Because this one only has 2 to give me. And then z's, I have 3, and then 5, and then 9. 3. Z to the 3rd is all I can take. This one has 9, but this one only has 3, so I can only take 3 from each piece, all right? And then I write what's left over. So if I take a 3 out, 1 is left over, right? If nothing's left over, I put 1, okay? X to the 4th and x. X to the 3rd, okay? If I take 2 y's from 7, y to the 5th, and if I take the z to the 3rd out, he's gone, right? Minus, okay? 6 divided by 3 is 2, so that'll be a 2 there. If I take this x out of there, he's gone. If I take 2 y's from here, y is left over, and if I take 3 z's from here, z squared. Okay, now with the 27, how many times does 3 go into 27? 9. If I take an x out of here, x. If I take 2 y's here, none, and z to the 6th power. Done. Okay, good? That's the factoring down. Now this one is not set equal to 0 because you can't solve for x, y, and z at the same time. So when it's not set equal to 0, you write that as your answer and you're done. All right? This next one, we're going to set it equal to 0 and we're going to solve for it. This one is a difference of squares. How do I know that's a difference of squares?
Because
you can take the square root of both pieces, right? And difference, there's a minus in between. There's a minus in between. So what's the square root of 49? 7 and 7. What's the square root of 81? 9 and the x goes with the 9, right? And one of them's plus, one of them's minus. Equals 0. Now when it's set equal to 0, I set both pieces equal to 0. So 7 plus 9x equals 0. And then what? And 7 minus 9x equals 0, yeah. Okay, so let's solve this one. What are you going to move? Minus 7. 9x equals negative 7, and then what? Divide by 9. Divide by 9. X equals negative 7 over 9. Okay, now I don't even have to solve this one because x equals positive 7 over 9. Thank you. I do. Yeah. Good? So that was a review of greatest common factor, difference of squares. Yes? If you feel like you need to write that down, great. Okay? That wasn't one of your homework problems. That was just review. Yes? Good? Did you do 1 through 12 on your homework assignment? Yes, you did? Great. Hey, do you have questions over your homework assignment? Yeah?
On the back.
On the back? Okay, we'll just wait for those.
Oh,
okay?
alright.
Okay? All right, let's wait and ask questions in a little bit, or maybe Thursday when we turn this in, we can ask questions, okay? So, greatest common factor difference of squares. Go back to the note sheet, okay? Your notes are filled in up until, I think we did like part B together, right?
Yeah.
Okay, so we need an A, C, and D, all right? A, C, and D we have to do. We're going to do this in a weird order. We're going to do A first, and then we're going to do D, and then we're going to do C. A, D, C, all right. So the first two methods, greatest common factor. Second method, difference of squares. Okay, greatest common factor, difference of squares. Now, here are the next two methods. Are you ready?
Yeah.
Here are the next two methods. This one is a simple trinomial. And this one is a complex. C we'll talk about later. Okay. One of them is a simple trinomial, one of them is a complex trinomial. I'm running, bleh. I don't have enough spit in my mouth to, bleh. Spot mouth. Okay, simple trinomial. All right, guys, listen. Shh. How do I know that this one's simple and this one's complex? Yes. Hey, are you guys listening? This one has just x squared. This one has a 4x squared, okay? So when there's a number in front, that's bad. That makes him complex. That 4 makes him complex, all right? Now, how do I know he's a trinomial?
Because he has three.
There's 3 pieces. 1, 2, 3, 1, 2, 3. Both of them are trinomials. All right. Now, simple trinomials. We've done these before. You just break them down into 2 pieces, okay? One thing that I want you to do, there is a typo in A. It should be 16 and not 6. Okay? It should be 16 and not 6.
How do you know that?
Okay? Because I know. Because I looked in the book. Because it didn't work out. Okay? So that should be a 16. So fix that really quick. Okay? Now, when you're doing a simple trinomial, you say to yourself, what can I multiply together to give me 64, but when I add them, give me 16?
8.
What?
8.
8 and? 8 and 8. Yeah, 8 and 8. 2 8s. What did you say back there?
8.
Oh, I thought you said 18 maybe. Okay. 8 and 8. So x plus 8 and x plus 8. Okay? X plus 8 times x plus 8. Now, when you do this, go back and check yourself to make sure one of them shouldn't be negative or one of them should be positive when you made it negative. 8 times 8, does that give me 64?
Yeah.
And positive 8 plus positive 8, does that give me positive 16? Yes, so we're good to go. Now, we set those equal to 0. X plus 8 equals 0. And if I subtract 8, x is negative 8. Yeah? Good? Okay? Now, the other one, if I set this one equal to 0, what happens? Also negative 8. Also negative 8. We're good to go. Good? Yes? That's it. All right, now, the complex one. Very similar after you get to a certain point, okay? In the complex one, you remember what we do first? I know you guys have done this before. This is the one that I call Cody's method. Have we talked about Cody's method before? Okay. Cody's method, named after Cody Mans because he hated these, okay? Cody's method, what you do to start with is you multiply the 4 by the 121. So I'm going to write multiply A and C together. Okay, A is the 4, C is the 121. 4 times 121. 484. Okay? Now, we put that on a little chart. We put that on a little chart and we say, what can we multiply to get 44? But when we add them, give us negative 44. Okay, and if you don't know, you just start listing. So 1 and 484 is not going to do it, right? 2 and 242. 2 and 242. Can I add those together, give me negative 44? No. 4 and 121. Is that going to work? Nope. 5 doesn't go in there. 6 doesn't go in there. 7 doesn't go in there. 8 doesn't go in there. Somebody said 22 and 22. A bunch of people did. Cody said it. So did Jerome, I think. Did you? 20, and McClain, he just wants to add it in there, so he's smart. 22, 22. Okay? Now, the problem is I want negative 44. Now, both of them are going to be negative. Because if one of them is negative and one of them is not, it comes out to be 0, right? Okay? So both of them need to be negative. All right, now, here's the magical part. Listen to this. Watch this. Write this down. Shh. Watch this. Write this down. This 4x squared is not going to change. The 121 is not going to change. Okay? Those just get rewritten. That goes there. That goes there. Okay? But the middle piece, the negative 44 becomes negative 22x minus 22x. Okay? So that if I would shove those back together, if I would do minus 22 minus 22, it would be negative 44, right? If I would put those back together. Okay? Now, the thing that people screw up all the time, are you ready for this?
Yep.
The thing that people screw up all the time is they'll write minus 22, and then forget the x on the end of it. Don't do that. Minus 22x, minus 22x, and then together those make 44, okay? So now we have it to this point. Now it is super easy. Super easy. The next part, all you do is put parentheses. You group them, and then you break stuff down. Okay, group it and then break it down. So this first part, not yet. We're not done yet. Okay, 4x squared minus 22x. What goes into both of those that you can pull out?
2x.
2x. Okay, so I'm going to pull a 2x out. If I take a 2x away from 4x squared, what's left over? 2x. And if I take a 2x away from negative 22, minus 11, right? You see that? Okay, now let's say I pull, what am I going to pull out of negative 22x plus 121? 11. Okay, now if you pull 11 out, it will be the wrong sign. You need it to be negative 11. So if I pull negative 11 out of negative 22x, that will make it positive 2x. What about if you pull negative 11 out of 121?
Negative 11.
Negative 11.
Okay.
And Elena says, I know why I said that because I don't have her in class. She says, I know that I'm doing it right because this guy and this guy end up being the same thing, right? If I pull those out, 2x minus 11, what's left over?
2x minus 11. Oh my gosh, it's so funny.
2x minus 11. Now, it won't always be that that's both 2x minus 11. We're going to do one here in a second that's not. Okay? So that's like 2x minus 11 squared. I'm just going to leave it like that and not put it as 2x minus 11 squared. Let's just do equals 0 for both pieces.
We gotta solve it from there?
Yeah, because it's equal to 0, right?
What?
Woo! It's not hard. It's not hard. 2x minus 11.
It's 11.
Plus 11 plus 11. So 2x equals 11. Whoever said that? Yeah? Divide by 2. X is 11 over 2. We are recording. 11 over 2. Now, what if I do the second one? What if I do the second one? It's the same thing, right? 11 over 2. There you go. Nope. Yeah. Really, you don't need to write both of those answers twice because it's the same number, right? You can only just do it once if you want to. All right? Good? Happy with that? All right, let's go to the back side. Before we do part C, we're going to do these two. Okay, we're going to do these two. All right. Letter A. X squared plus 9x plus 20. That's a trinomial, right? It's 3 pieces. Is it simple or is it complex? This one is simple. It's just x squared, right? So this one I just break down. What can you multiply that gives you 20, but when you add them gives you 9? Multiply to get 20, add to get 9. 5 and 4. Does it matter which one you put first? Whoop, 4. X plus 5, x plus 4. Okay? Now, if you set those guys equal to 0, if you say x plus 5 equals 0, what's x equal? Negative 5. And x plus 4 equals 0, so x equals negative 4, like that. And you're done. Those are nice. We like those. Right? Those are easier. Okay? But then these ones, part B. What kind is he? He's complex. Okay? What do you do for complex?
6 times
Brooklyn.
20.
Quit distracting them. What?
You multiply the A and C.
You multiply the A and C together. 6 times 20 is 120. 120. Now, What can I multiply to get 120, but when I add them, give me negative 23? If you don't know, just start listing. 1 and 120, that's not going to work. 2 and 60. 3 and 40. 4 and 30. 5 and 24.
Yes.
What?
6 and 20. 7 doesn't go in there. 8 and 15. Which one? 8 and 15 add up to be 23, but
It's a negative.
both of them need to be negatives. Negative 8 minus 15. Okay, so this 6y squared stays the same. 20 stays the same. And then the 23 becomes whoop, minus 8y minus 15y. Like that. Okay? Don't forget the y's on them, or on there. 8 and 15, when you put them together, make negative 23, like that. Ugh. Okay? Now I group them. Now you group them. What? We're almost done. Just wait. What can go out of the first piece? What can come out of the first piece? 2 and y. And left over is? 3y. 3y minus 4. Okay, what comes out of the second piece? Negative 5. And left over is?
3y minus 4.
3y minus 4. So, and now I know I did it right because those two pieces are the same. 3y minus 4, if I pull him out, what's left over? 2y minus 5. 2y minus 5. Okay? Now, we're almost done. Set equal to 0. 3y minus 4 equals 0. And 2y minus 5 equals 0. Okay? Then, on the first one, 3y minus 4 equals 0. You're confused? So the 3y minus 4s were what was in parentheses. We yanked that out. And left over is 2y minus 5. Yeah? Okay? 3y minus 4, we set that equal to 0. We add 4. And then what?
Divide by 3.
Plus 4, so 3y equals 4. And then divide by 3. So y equals 4 over 3e. Okay? And here we add 5. 2y equals 5. Divide by 2. Y equals 5 over 2. Now, we haven't done this yet today, but what do those two numbers mean? The zeros, which mean this parabola crosses at 5 halves, which is about here, and 1/3 or 4/3, which is about there. So that's what he looks like. Okay? That's what he looks like. All right, we're going to skip this example 5,
Heck yes.
but we are going to go back and do part C, because we didn't do that one yet.
Are we not?
What?
We're not doing
We're not doing example 5. Okay?
Thank you.
So, C, x squared plus 225. Okay? We need to figure out what he is, all right? He's not a trinomial. How do I know that?
Because there's not 3 parts.
There's not 3 parts, so he's not simple or complex. So those 2 are gone, right?
It's just
Now, he is, just wait a second. He is not a difference of squares because difference has to be minus, right? So it's not a difference of squares.
Difference plus squares.
It's like the sum of 2 squares, right? So how do I
so
factor
sum of
that down?
squares.
How do I
There we
write
go.
that down?
Sum of squares.
Okay? You can break it down like they do in the table, but I do this. This is what I do. Let's subtract 225 from both sides. X squared equals negative 225. Okay? Do that. X squared equals negative 225. Then, square root. X equals. Okay, now, here's the problem, guys. Here's the problem. Square root of a negative. What does that become? I. No. I. This is easy.
No, it's not.
What's the square root of 225?
15.
15. 15.
There's no solution.
Okay? And
Negative 15.
Positive, negative.
Positive, negative, plus and minus, because who put the square root in?
That one guy.
That one guy, that was us, right? Okay. Plus and minus 15i, which means that this parabola is going to be like all the way up here, right? They're not bad. There you go. That's it. That's it.
I need you.
Okay.
No, you don't.
Yeah, you're